Universal Design. Chapter 1. Introduction to Universal Design. Need for barrier-free environment. The progressive reality of 21st century India needs to extend these thoughts into practice of urban futures and built environments, which at times play a crucial role in disabling or enabling a human experience. Universal accessibility in a broader sense forms one of the key means to include all, ranging from persons with disabilities to other diverse user groups in the urban Indian context. Creating human-centric, safe and inclusive environments for all will perhaps be the surest ways to prepare for the demographic transformations and challenges of age, ability, gender and cultures in Indian futures. Key elements of an urban built environment: information systems, infrastructure developments and their internal services play an active role in shaping one's accessibility experience. Persons with disabilities, elderly, women and children along with other vulnerable population groups like ones with terminal health conditions, expectant mothers, persons with obesity or other invisible disorders, etc. need to be considered at all levels of design and planning decisions in built environment and services along with procurement and implementation processes. The Harmonized Guidelines for Universal Accessibility 2021 succeeds the earlier version of Harmonized Guidelines 2016 amidst new transformations and visions for urban futures and built environments in India. The new guidelines and standards complement the parallel existence of the National Building Code 2016, Model Building Bylaws 2020 and other relevant codes while adhering to the mandates of the Rights of Persons with Disabilities Act, 2016. Progressive national policies and campaigns towards implementation of accessibility in various facets of Indian built environments shall further render these guidelines. Principles of universal design: equitable use, flexibility in use, simple and intuitive use, perceptible information, tolerance for error, low physical effort, size and space for approach and use. 1. Equitable use: the design is useful and marketable to people with diverse abilities. 2. Flexibility in use: the design accommodates a wide range of individual preferences and abilities. 3. Simple and intuitive use: use of the design is easy to understand, regardless of the user's experience, knowledge, language skills, or current concentration level. 4. Perceptible information: the design communicates necessary information effectively to the user, regardless of ambient conditions or the user's sensory abilities. 5. Tolerance for error: the design minimizes hazards and the adverse consequences of accidental or unintended actions. 6. Low physical effort: the design can be used efficiently, uncomfortably and with a minimum of fatigue. 7. Size and space for approach and use: appropriate size and space are provided for approach, reach, manipulation, and use regardless of user's body size, posture, or mobility. Types of disabilities. Accessibility needs in the context of built environments for diverse user groups provide a specific yet generic perspective towards creating enabling built environments for all. While the following chapters specify details of various elements of built environments, this section provides a broad perspective on the various attributes of accessibility for persons with disabilities. Physical disabilities. Visual impairments. Hearing impairment. Speech impairment. Cognitive impairments. Neurodiversity. Multiple disabilities. Physical disabilities. Persons with disabilities do exist in diverse forms and with varying degrees of disabilities. Certain disabilities of physical nature may be visible through body structures while several disabilities impair the invisible body functions which may require adaptation at various levels in built environments. Some of the common accessibility needs for diverse disability types in built environments are stated below. Ambulant disabilities. Non-ambulant disabilities. Ambulant disabilities. This includes persons with lower limb difficulties which may be temporary or permanent in nature leading to requirements for body support, slow movement, etc. Persons with ambulant disabilities may use assistive devices like crutches, cane, walking frames, rollators, etc. while some may move without assistive devices. B. Non-ambulant disabilities, wheelchair users. Non-ambulant disabilities may occur as a result of various reasons, either naturally or due to an accident. Persons with non-ambulant disabilities may use wheeling devices like wheelchairs, manual, powered, etc., or tricycles or ground mobility devices as assistive technologies for their mobility needs. Negotiating levels in built environments remains a critical challenge to their accessibility and safety needs. The following features may enhance accessibility: parking spaces with wider access and circulation, step-free and wider entrances with adequate landing spaces for wheelchair or powered chair maneuvering, etc. Adaptive spaces for wheelchair users in outdoor and indoor environments. Provision of ramps with gentle gradient, edge protections, grab rails and non-slippery surfaces. Clear space of 900 mm minimum for all circulation areas like corridors, doors, street bollards, etc. to accommodate a wheelchair user. 2. Visual impairments. Visual impairments include various forms of sight-related disorders ranging from low vision to peripheral loss of vision to partial or complete blindness, etc. A. Low vision. People with partial loss of vision can usually find it very difficult to navigate in and around the built environment, especially in unfamiliar settings. While excessive contrast can create problems of glare, inadequate contrast can make it difficult for persons with low vision to discern objects or details in the environment. Adequate visual contrast in level changes and surfaces. Adequate illumination. Larger font size in signage. Effective color combinations keeping in mind the needs of the color blind. Glare-free light. High resolution, readable characters, for example with LCD. Use of assistive technologies like screen magnifiers, screen readers, text-to-speech or voice recognition software, etc. Obstruction and protrusion-free paths for movement. Avoid slippery, blindness. High contrast environments. Provision of tactile pavers guides people with visual impairment to move independently. Provision of safe and level pedestrian crossings in street environments. High contrast color markings at the edges wherever there are level changes. Braille plates as information systems to be integrated with elements like handrails in staircase, ramps or grab rails in circulation spaces. Provision of multilingual signage along with Braille. Tactile floor plan or tactile models with consistency to be provided for in-built environments, especially public buildings, transportation hubs, etc. Use of digital signage system with audio-video public announcements. Good acoustic treatment indoors which does not distort sound. Radio frequency identification systems and new state-of-the-art technologies for enhanced sensory communication may be employed to enhance accessibility in mobility and other functional spaces of built environments. 3. Hearing impairment. Hearing quality is crucial for communication of information or detection of hazards while moving through a range of built environments, especially in high traffic zones or environments with high background noise. Hearing loss, HL, is classified as mild for HL in range 26 to 40 dB, moderate for HL range 41 to 55, moderately severe from 56 to 70 dB, severe for 71 to 90 dB and profound HL for range 91 dB or more. Considering a range of HL across individuals with hearing impairments, built environments need to reinforce their visual order communication systems, especially for emergency services and evacuation, to ensure that persons with hearing impairments are not neglected. Built environment spaces and infrastructure needs to facilitate oral or sign language communication through its operations and services to be inclusive to persons with hearing impairments. 4. Speech impairment, facilitation of two-way communication to minimize barriers to hearing low and indistinct speech. Use of appropriate wayfinding, signage systems. Use of efficient wayfinding system which allows a user to reach a destination independently. Use of visual icons or pictograms in addition to text characters. Use of digital signage system with audio-video public announcements. 5. Cognitive impairments, provision of physical and sensory cues such as touch, sound, smell and tactile or audible information. Simplified designs, layouts for ease in mind mapping. Challenges faced in built environment, inaccessible information design at bus shelter. Barrier in wayfinding map legibility. improper parking management, absence of adequate visual contrast in steps, inaccessible entrance with inadequate visual contrast in steps, challenges faced in built environment, improper ramp gradient and slippery floor finish, curved ramp with improper detailing and design, absence of kick plate and lever handle, improper ramp detailing, rumble granite strip on ramps as a barrier, inadequate visual contrast, improper edge detailing of level change, challenges faced in built environment, inaccessible heights for wheelchair user and children, improper ramp detailing and management, typical barrier in built environment, inconsistent tactile markings and physical obstruction on sidewalks, inaccessible counter heights, high curbs and absence of curb ramps near zebra crossing.